article is just saying that back from 1993, we have a lot of search engines, and search engines have evolved very frequently. Now, like, search is everywhere. You have like images, music, videos, health, shopping, cooking, finance, jobs. So each of these domains have their own search engines. The kind of tasks you do. So now, I mean, this talk is going to be a lot of task stuff. So the tasks you do on Google, on images, on Google image search is like you have an image, you find images. For music, the task is that you have to find music content which is relevant to you. In videos, the story goes on. So search is everywhere, and okay, so this is where search started with Google in 1998, and this is where it is right now. So so you used to query, get a set of results, and now you have a more richer interface, which is like algorithm results. This is what we at search engines call algo results. This is like the news answers. These are entity panels, which you kind of pull up from Wikipedia and stuff like that. So in general, now for an entity like UCL, you are showing richer content to users. So the search has evolved in the last 15 years or so, but in general, it's still the same reactive content. I issue a query, it will give me a set of results which are relevant around it. But this is some search volume from the recent WWW website. You have like 3 billion searches per day at Google. This is like 30 trillion unique URLs, 20 billion sites, and 60 trillion web addresses. Nothing much bigger we can get at that. But yeah, this is an interesting slide. So when we started off, so if you're talking about search engines like Google, Yahoo, Bing, and others, Yandex is in Russia. So they started off with classic information retrieval, which is like you issue a query, you get a set of results. But then people started moving towards, so this is like more of the library content in 1980s and 1990s. People started going towards web-based information retrieval, which is queries could be navigational, informational, or transactional. So it's like a lot of times these people issue queries like Facebook. So even though you know that Facebook.com is a website, but we would probably just go to Chrome and type in Facebook, and it'll autocomplete and go to Facebook. But a lot of times what you see is like that older people, they kind of go to Google, type in Facebook, Facebook.com comes with the first result, you click on it, and then you kind of go to Facebook.com. So these kind of queries wherein you know that you're going to a specific website, these are called navigational queries. And one important thing, and information queries is like that you want to search for something, like you want to find the address of this place, aspiring minds, you want to find about aspiring minds, type in a query, you look at information from the results. So are you guys aware of entropy, click entropy? Yes. Okay, so one interesting point, so entropy is something which measures how consistent or how homogeneous, heterogeneous the system is. So when you're looking at navigational queries, for navigational queries, if you look at the set of results, people are always going to click on Facebook.com. So it's like you have a query, you have 10 results. If people are clicking on the same, it's like hundreds of you query Facebook, and if everybody clicks on the same link and nobody clicks on the rest link, then the click entropy is low because they're clicking on just one link and not the other link. But if for information queries, some people might be interested in the location of the aspiring mind, some might be interested in who the founders are or what kind of research they do, what kind of work they do. So they click on a lot of different results. So when that happens, then you see that, okay, because people are clicking on a lot of results, so the click entropy is high. So if you just have to build a classifier, whether a query is navigational or an informational, then you can just measure, there's a mathematical formulation of measuring click entropy. You can just compute the click entropy and then see that if it's less than certain threshold, then it's a navigation query. If not, then it's an informational query. This is just a brief thing. If I'm speaking too fast, just let me know when that's slow down. So this is like early 2000s, but then people started looking at, now we want to personalize and kind of cater to the needs of people more. Then comes in the direct answers. If what used to happen previously was that if you want to find the time in London right now, then actually it's like just 5.5 hours behind. But then if you search on Google London time, it will give you a result like some datetime.com, and then you go on it. But then that's like tedious. Now what they started to do was they started giving out the results over there itself. The time in London is this, you have an answer box, which is a direct answer. If you have to search for currency rate or weather in Lucknow right now, they will give you a direct answer. So this started happening back in 2008-9. And then a lot of different companies started doing that. Now, since the last 2-3 years, people have been talking about more assistance. That if assistance in general means that if you are doing something, then they would like to personalize content for you. So it's like if you're searching for SVM. So SVM for machine learning people would be support vector machine. But SVM might be some company name in Varanasi. So people over there might kind of get different results. So based on your topical profile, search engines in every company personalizes content. So that personalization is a layer which constitutes the assistance part. So this has been going on at every company. Like somebody was mentioning about personalizing user modeling, personalization. Somebody talked about that. So in personalization, you're trying to anticipate that given these 5 things, what is one thing which the user might be interested in? So you build a user profile of that user and try to see that, I mean, is this important to the user? So I'll show this, otherwise I'll show something else. So that's like assistant. But now, this is coming in from one of the top tier conferences last year. There was a keynote talk by some big researcher at Google Research. So he filled that question mark saying that the next thing which is going to happen in the next few years is task completion. So this is where my entire PhD work is based on. When you're talking about task completion, imagine that whenever I open my browser, I have some tasks to do. Maybe it's like finding some movie tickets. Maybe if you not with just browser, if you just pick up your phone, you have a task you want to do. Like if I have to find Uber, I have to book a movie ticket, I have to find a date on Tinder, I have to buy something from a girlfriend or anything. So whenever you use any digital technologies, you are trying to do a task. And I mean, so this, if you look at this hierarchy of things, then the next thing people are talking about is how can we help users complete their task pretty quickly. And this is what this talk is going to be about. And so this is some work which is ongoing at, I mean, at least from what I know, I've talked with researchers at LinkedIn. So when you're on LinkedIn, then if you want to search for a new job, then LinkedIn wants to know that what your task is. Are you trying to switch fields? Are you trying to find a better paying job? Or if you're a recruiter, are you looking for some candidates, or if you're looking for collaboration stuff? So that's tasks for them. For tasks for companies like Amazon and eBay, so at eBay or Amazon, the task would be that if you have to find a gift for your mother on Mother's Day, that's your task. So, and then if you know what task you're looking for in a shopping website, then you can show recommendations based on that. On search engines, it's like I have to find. On search engines, the basic task is I have to plan a trip to London. So, if planning a trip is a task, then you issue a lot of queries based on the different subtasks. So, first of all, you will book flights. So when you book flights, you will issue a query that, okay, I have to book flights to London, so you make my trip another result. But the moment you issue a query flights to London, the search engine doesn't know what your task is. Overall, in our head, we have this hidden task that we want to plan a trip to London, but the system is not aware of it at all. But if as a user, if as a system, I know that, okay, the user is trying to kind of do this task of planning a trip, then I know that eventually in the next few days, he's going to look for hotels. He's going to look for the currency in London, or if you're a vegetarian, you're going to find vegetarian restaurants over there, and you're going to find how do you kind of move around in London, what are the good places to visit and stuff. So the moment you know what task the user is trying to do, then you can do a lot of stuff. You can kind of give contextual recommendations, suggestions, advertising, proactive. Like if you have seen your card on it, can just show you cards while you're there in the evening to choose that these are the vegetarian restaurants nearby and stuff. So task completion requires task understanding, and this is where my PhD work is currently based. That we want to kind of find out what task the user is trying to do and help them complete that. I'm just going to skip it because it's not visible at all. So, I mean, just a brief, whenever you see any such graph like this, these are kind of heavy tail graphs. So if you're looking at queries, so some of the queries are like, imagine not that graph, and it's like, have you seen some photographs of casinos, right? So they have like certain machines, you pull around and then you get some reward. You have different machines. So if you have 3 machines, you pull one machine, you get like 5 rupees or $5. If you pull the second machine, you get $10. If you pull the third machine, you get $3.
Are you talking of slot machines?
Slot machines, yes.
Okay.
So in general, over there, if you have let's say 5 machines, you do not know which one is the most rewarding. So then what you have to do is like there is a trade-off between exploration and exploitation. So let's say you have, or let's say we talk about 5 different options. You know that you explore the first option, you get let's say a reward of 0.5. You explore the second option, you get a reward of 1. If you explore the third option, you get a reward of 0.2. So now you just have 1 chance remaining. So there are 5 machines, you explore 3 of them, you know that the second one gives you the most reward. So now either you can exploit the knowledge you have. You know that in these 3 machines, given a new chance, I will pull the second one because that gives me the most reward. This is exploitation. Exploitation means exploiting the knowledge you already know. But there might be the 4th machine which gives you a pay of 10, which is like 100 times more than the first 2. So this is exploration. So now, I mean, you can explore, you can look at a new machine and get more reward or less reward, or you can exploit based on what information you already have. So you can, I mean, this is the explore-exploit trade-off bandit algorithms too. So a lot of these online systems. So in 2011, the Yahoo News results, they kind of implemented this first production system which has this explore-exploit, and it's like this: that if you're on Yahoo News, then either it can show you results from your history and show you just news about that, or with some certain probability, it can explore a bit more, show you results of astronomy. which you have not shown any interest in, and maybe you get interested, you click on it and kind of do that. So this is like the explore, exploit, valid settings. So if you're interested in this, you can just search for that.
No, but why are you not supposed to talk about it?
I mean, that's because it completely digresses from my topic.
Oh, I thought it was like hidden kind of a topic, not to be.
Oh no, it's like hugely popular. A lot of people are doing it, and all this I was not supposed to talk about. I was supposed to proceed with there because we have time requirements.
Yeah, coming back to digital assistant,
right.
While watching my conference of Google and Apple,
right.
they are showing off their digital assistant, Google Now and Apple CD.
Right.
All I can interpret that they are showing off their NLP and deep learning. So I'm on the right track or what?
Okay, so this is like it depends on what kind of information you're looking for. A lot of these models are deep learning models now because the first entry point for a digital assistant is that you are speaking to it in voice. And all the voice-based systems which are functioning right now, they are working on deep learning models.
Exactly.
So, I mean,
so that will be speech recognition via deep learning, right?
Yeah, that's speech recognition via deep learning.
Yeah, when we get a sentence structure, then we should go for NLP via deep learning.
Via deep learning or via some other thing?
Because everyone is using deep learning and they are showcasing
that.
This
is what happened. Back in the 1990s, everybody was using STM. So for 1998 to 1998, everybody was talking about STM are the only thing to support better machines. Since 2000 to 2009, a lot of people were talking about logistic regression. So all the companies, LinkedIn, I mean, just Netflix, Comcast, LinkedIn, everybody has their core algorithm as either a decision tree or a logistic regression. That's like the production level details. So till now, I mean, so LinkedIn's current ranking system, a lot of these things, so it's like LinkedIn has this people you may know feature, right? So that is based on an ensemble of decision tree and logistic regression. Because these are things which work. Deep learning is something which you need a lot of powerful machines to do, but so, I mean, logistic regression is like people underestimate it a lot. I mean, in my PhD for the past 2 years, I thought it's like the first thing people study, so it might not be that important. But when I was giving interviews, everybody was asking for logistic regression, their questions. And then when you talk to these people that, at the end of the day, fine, this is all research, but what actually works? I mean, when I was interacting with you initially, then my first frequent question was, does it actually work? A lot of times what you see is that even though these Bayesian techniques are really good, but they may not work. Logistic regression almost always works with some certain accuracy. So if you're starting out, if in your company or in your startup or a new project, if you want a system, you don't give a shit about deep learning. You don't, I mean, if you want to sell it to some advertisers and stuff, then you know, okay, our model is deep learning based and stuff like that. But if you want more accuracy, quicker accuracy, then just implement a basic logistic regression model, get some good results. Now if you want to improve on it, then maybe use explore, exploit, maybe use deep learning or Bayesian techniques or whatever. But in general, this is like, because startups favor this quick iteration thing, logistic regression is like simple to implement, just have a set of features, get the first version out.
But the problem with logistic regression, you have to find the features.
Exactly.
So deep learning does not involve that problem because our neurons will actually find that problem.
Exactly. So in general, there's a trade-off. So if you have lots of data, then you can train a deep learning model of it. But if you don't have a lot of data, if you're a startup, if you just have a few hundred users, 3,000 users, but a lot of these times you have domain insights. So in neural network, these deep learning models, you cannot encode this insight somehow because that's a black box to you. You know, okay, I'm going to train this huge neural network, whatever it is, it's a black box to me. We haven't talked about it. But I don't know what is working. If I want to add this insight, that, I mean, if you want to do this, that if people hovered over this result and didn't click on it, then that means it's not really relevant. So this is one domain insight I might have, and I want to incorporate in the model. You cannot do that by deep learning. But you can add it as a feature in your logistic regression or any other lambda model or decision tree as a feature, and then you can incorporate that stuff. Or you can do an ensemble of things. So it's kind of a trade-off. I mean, nothing works for everyone, and if you have more data, then deep learning works. Most of it is like, so I was at one conference last week, and 70% of the papers had some sort of deep learning into it, but the truth is like, so there are different time frames for different trends. Bayesian non-parametric was kind of famous from 2008 to 2013, 2012. Now deep learning is famous. So now people have been, so in my work, we have started to use deep learning as just one feature. We don't kind of overhype it that our model, I don't care what works. All I care is what solves the problem. If it's like Bayesian, logistic regression, or deep learning, I can use any combination of that. How much time do you have?
You can take as much.
Okay, sure. Yeah, because we have, I mean, we just stop whenever you get.
No, yeah, you can take as much as you want.
Okay.
I just have a question. I thought deep learning and other things on specific with deep learning was relatively computational intensive. Now the lectures that you guys are using, that's why we are exploring it. Second, nature of query. I think the other case another we're only going to track that nature of query. For example, you can say your method for now based on some inputs we are doing, observing. The deep learning can actually tell you how you run your cycle. So I think the domain of query is separate. These two are relevant things. Third, I think researchers in general are funding. In general, I do agree with you that whatever works in computationally intensive deep learning data set, it will take time on that. Not resolving any adaptation.
Exactly. That's
I
like the
don't know how Google recognize the deep learning experience. I know how that research works and voice search I don't know how it is guiding me. Supposed to be a this problem should legally obstrucate my voice because otherwise everybody something that is being done. Putting a lot of stuff in giving me the deep learning is part of what's computationally exhaustive nature. One problem.
I agree. I mean, these are like perfect 4 points to summarize. I was trying to train a deep. So yesterday we submitted a workshop paper, and I have to run some models on it. And I wasn't at UCS. So deep learning algorithms are like they work, but they require a lot of computation. So I have a MacBook Pro which is like this 8 GB, and if I have to run a model on it, I mean, this has been running for like 2 days now. And I mean, since it was running until yesterday, so even when I was on the flight, I ensured that the laptop is not closed and stuff. And then suddenly, like, out of the blue, my mom decided to kind of disconnect the power supply. And then, I mean, then kind of the laptop switched off, and like I have to retrain the whole model and stuff. So this is like, deep learning models are really prohibitive to, computationally intensive to kind of train. But then if you have lots of data, and there are some problems which, I mean, if you have a lot of domain insight. So traditionally, just give a brief background of why people, the pro and cons of deep learning and such. It's like, this is a debate which can go on for like days and decades. But a lot of times what happened was that,
Friday you go on into CP, in Zomato you search for something, and you say, I want the cheapest beer now. Zomato cannot give you that detail. You can look at some stuff, what deals are going on. Elementary algorithms will give you this kind of information. Maybe build a recommendation engine and some sort of key performance indicators of your activity. And so, deep learning algorithms will actually see and identify, are you going to date? And is this the kind of order that you are doing? And based on that interaction, is this really relevant activity? Is it your birthday? Is it like, that's the difference between average and a Jarvis kind of a system in, so it is Iron Man. So deep learning is Iron Man, Jarvis. That's what I want you to, visualize. For HR, I have never found API which is worthy of mention. How can you mention somebody? I truly do not believe that one resume can actually differentiate from another. So I'm just throwing it at you. I don't have an online profile at all. I won't qualify in any system.
yeah, and also like if you even in the resume
I'm just
domain,
relating the example to what is going on in his screen. Satisfaction. He's discussing a restaurant opening. There's no such way for Zomato to do it right now. I can't even visualize how they will do it 2 years from now. That's what I was sharing.
In my kind of context, probably Zomato will be out of the scope. If I need beer, then Zomato should not be.
Also, in your context as such, you're looking at recruitment.
5 skills and
Yeah. So matching to jobs, right? So if you show some job to users and you find out that they weren't interested in that, they have some feedback mechanism to show that I recommended this, it didn't work out, so now I'm going to kind of remodel my model and say that, okay, instead of this, look at this, and then show it to the user as well. So basically it's about incorporating some feedback from what you show and then evaluating your own results. Did I screw up? I mean, if I talk about this, if I showed him this job and he didn't like it, maybe it's because of the location. He doesn't want any job in Bangalore. He wants to stick in Gurgaon. So you want this kind of a feedback system that you're showing something, you're incorporating these implicit signals as feedback, and then you're deciding whether or not I did the right job. And if you didn't, then something needs to be redone. But overall, I mean, it's like if you step through the last half an hour, then we were talking about that in general, you have these online interactions with users. You should have a way of recording these implicit signals as feedback mechanisms, and then you can retrain the model based on the data you have. And we were doing it in the context of these digital systems. And how this relates to what I'm going to talk about next is that these sessions could be multitasking sessions, even on Amazon. Like you can search for gifts for yourself, gifts for your mom in the same session, and then you want the system to be able to discriminate between the tasks and stuff, and then do recommendations. Maybe you're searching for some movies. Movies is kind of different domain. On search engines or any other platform, you can kind of. It's important for the system to know what task is and where the user is switching between one and the other. So this is where we bring it to the next thing, like search task. Everybody now have a feeling of what these tasks are as such. I'm just going to give an official definition. So it's kind of at least in the context of search, it's an atomic information need that results in the issuing of one or more queries. So it's like, so this is one example of a task somebody is doing. Like she's finding hair salons in New York, looking at train timings and how to color hair and need train directions and then getting some hair salons and such. So now over here, this is one session which is a multitasking session. Which is that this is one task, already doing this is another task on the train. So now you have, in general, when you see user interaction, this is what it looks like. And these are hypothetical treasure maps, secrets, Indian Ocean directions, nobody's going to search for that. But in general, this is what a user session looks like, and they are kind of interlinked. I'm just going to skip this. Okay, so now forgetting everything else, the research problem statement for us becomes, given a set of queries, how do we disentangle the different tasks as such? Now, ideally, I want to have these three queries together in one task, which is like finding the salons and stuff, and this is like train and train directions. So this is one problem. This is like a very simple task. This is like one session, two tasks, how do we separate them? There are a lot of things which work pretty nicely. You can have long-term task extraction. There's a paper which looks at each query, tries to link with the other queries, and sees that, okay, if this is a link, that's fine. If this is again a link, then you kind of cluster them together and stuff. There was a lot of things you can do based on this. One is you can do in-task personalization. That right now, if this is a task you're doing, then I want to personalize based on that. You can do cross-user collaborative around. This is something which some of you were mentioning previously, that if I might be a kind of a very novice user in DSLR cameras, but there might be some expert who would appreciate queries. Then you can look at collaborative ranking, which is like finding similar users, getting their results and showing it to me. You can do that kind of stuff. Then you can do search task satisfaction prediction, that given this query, was the user satisfied in completing this task or not? So in general,
Sorry, what was the last thing that you mentioned after cross-user collaborative ranking?
it was search task satisfaction prediction, because you don't know whether the task was satisfied or not. So I'm just going to walk you pretty quickly through the next set of slides. So we focus on multitasking user groups. We're not going to focus on any of it. We're just going to walk through the results. In general, some data summary. I mean, this is like one of the papers we wrote. So we had around so this is like a couple of weeks of search logs, a subset of that from Bing. Apparently a lot of people use Bing. 21% of search traffic is from Bing. So I cannot officially comment on how good or bad Bing is, but this is from Bing data. So we had around 620 million queries. The number of sessions were around 190 million, number of users around 2 million. So each session had around 3 to 4 queries as such. These are like real world logs from sometime in January to February 2016 this year.
How do we get that? Like if someone wants to have that
Yeah, you cannot. I mean, it's like you need to be in. I mean, so that's why I spend most of my. So I'm doing my PhD in information retrieval. Search data is not publicly available at all. So there is this AOL log which was published in 2006. So they have data on a lot of like around 3 million users. But so this is like search data for 3 million users in 2006 from AOL. So that's like some 10 years old data which you can use if you want to work on search. But in general, this is part of my work with Microsoft. So that's why we have data access over that.
Okay,
But from public, like apart from AOL, there is no public data set and such.
this is a snapshot of all searches at that time.
This is a snapshot. I cannot say a snapshot of all searches because then you can backtrack and find out the number of users and queries. So officially, I have to say that this is a subset of users.
None of us is advanced enough for that.
But so this is officially this is a subset of users. So this is like a subset of users from Bing. And in general, it's interesting to look. Like I mean, in general, a session lasts about 3 to 4 queries and such. And the number of sessions per user over a 2-week period is like 76. So you have 76 sessions in like 14 days, which maybe okay. But in general, the number of tasks people do per session is 2, at least more than 1. Which means that in general, you don't do one task per session. You do multitasking. Like you look for Facebook, look for music and stuff.
A task can have multiple queries.
A task has multiple queries. Yeah.
2 tasks having 3 queries. That's interesting.
Yeah, so you can do this adult songs, wedding venues, video download. This is like one session but 3 different tasks. And these are the corresponding topics and such. Then you can have Obamacare, running shoes, more shoes, wedding cards. So this is like, if you're looking at cross session, then this is session 92. Obamacare is like the 4th task, running shoes is like 5th task, but then sports shoes related to the same task. But then wedding cards is related to something the user was doing previously. So you have session ID, you have task ID, then you have the topics. So effectively it says that in multi-session, people can do a lot of tasks. Across sessions, people can continue tasks. Because maybe this session is on some different day than this, then you can resume the same task and stuff. A kind of trivia, in general in web search, we observe that 34% of the queries people issue, they have issued this before. So in general, across all the sets of users, we see 34 to 35% of queries which the same user had issued before. So there's a lot of refinding happening. A lot of these, so mostly it's navigation queries because if you've gone to Amazon, you're going to issue Amazon before, you're going to issue Facebook before. If you're a vegetarian customer, then you're going to find vegetarian restaurants, issue the same query. If you're tracking Wimbledon, then you're going to do this for like 7 days for the entire Wimbledon duration. So a lot of times these refinding happens, so it's not really useful, but then that's like 35% of queries are refinding.
I had a small question here, since it looks like a lot of this work is dependent upon getting the query column right? What are these queries? So when you have so many 620 million queries, how do you define queries into different categories? You know,
Yeah, so
this is this query, this is this query, this is this query.
Yeah, so
How do you know that adult songs is a query which can come into this particular list? Is it categorization?
So in terms of categorization, the only categorization we are doing right now is topics. And because, I mean, right now we are not categorizing. This is like you can do this for the entire 620 million queries, right? I mean, so you're considering all the spaces, all the queries, and all the tasks. So now that's the challenging problem. That I can look at a few subset of queries, do this manual task annotation stuff, but imagine 2 million users issuing 6 million queries, and they're doing like what 100 millions of tasks. So doing that in such a scale is like really mind-boggling problem. But initially I showed you that like the long tail curve of tasks. So even after looking at these 6 million queries, if you can find out what these common 1,000 tasks are, then these 1,000 tasks are in this head. So this distribution looks like head, body, and tail. Tail is like pretty huge. But the head queries are like hugely popular, and they constitute about 50 to 70% of your traffic anyways. So even if you pick up these 100 tasks which are like super popular among users and have built custom interfaces and custom experiences for that, then you're kind of doing a good job for a big amount of users as such.
Yeah. I want to ask the same thing for a different like this now. So if we have to like doing the classes of this search queries, like which will be in the arts, which will be in the sports. So will it be on the basis of the words or?
Yeah. So okay. So in general, okay. What actually so it's like established corporations. We have different teams doing that. So imagine that you can enrich this query with a lot of information. You can enrich it with the topics. You can enrich it with entities. So you know that Adele is like the single now. So the user just issues this query. now we have, let's say, one search engine which has 100 different teams. Each team has a responsibility to look at the query and attach enriched information from that. So what you can do is, like, one team can be the topic team, that they look at the query. Their job is to perfectly categorize the topics for this query. So then they can construct these features based. So if you have to, this is what happens when you have run deep models on your laptop. So when you're looking at these LL songs, these are just like two words. It's very hard for any system to look at two words and categorize into a topic. Now you want to kind of look at what URLs were shown, the content from the URL, the content from the click URL, and then aggregate all that and then run some classifier according to some topics. So if let's say you have 100 different topics, then you can have a classifier to classify these documents into different topics. And so it's that team's job. I mean, as a researcher, I don't care how to do it. I mean, because if I'm part of that team, then that's my job. Otherwise, there is some team who's enriching the query logs with these topical information. They kind of do it, build a system, they kind of iterate on it for, like researchers do, and then like they do it for you.
Sorry, not clear. What is the input to this team and what they give
So
out?
yeah, so the input to this team is like the query, the list of documents that are shown, and which documents were clicked, and historical information for this query. So I mean, if you're the part of this team, then you have all this information, and then it's your job to correctly classify this query into the set of topics you have. And as a different team, I might not care how you do it. It's yours. So
essentially, my job is to identify the task of that query which I have typed.
I mean, it depends. The overall point I'm trying to say is that different teams have different jobs, and then, so I mean, that's like an example of how you do research with that. So it's like if I have to work on task, then I will only concentrate on this column. How do we identify tasks? Then I'll assume that there is another separate team which does this topical information for me, so I can just use their results. You can also add an entity column here. That this is Adele, this is no entity, this is Obama, this is wearing sports shoe, running shoe, there is no entities over here. But then now entity information is like important. So you can kind of have another column, another team doing this entity stuff. So when you are, so that's like one of the, why I interned with Microsoft again was that, if you want to work on tasks, then I don't want to kind of get bogged down by doing topic tagging and stuff. Now you have different teams doing this, and then you can kind of use their information, pull it together. It's like super easy. I'm sure like people at Yahoo and Google also have these kind of architectures. And so now as a product team, if you want to design this inherently inbuilt in your houses, then you can have separate teams. Imagine the user queries are coming in. That's the only information you need. But if you want to do some analytics, then you can have different components coming in from different teams. Some team is tagging it with topics, some with entities, some with Wikipedia articles. Because even finding a relevant Wikipedia page to this is a challenge, because you have millions of Wikipedia pages. Now you want to tag this to, let's say, top 5 relevant wiki pages. So now some team is doing that, because the classifier for Wikipedia tagging would be different from the classifier for topic tagging and stuff. So now you have different teams doing this. Once everything gets combined together, then you have this log which is available for the business analyst. Or if you're a data science guy, then you can use this enriched information and then do whatever modeling you want to do. So that's how it kind of works, at least in the places I've looked at. So this is the distribution over the number of tasks. We have not talked about how we tag these tasks, but then about 22% of sessions have one task, a major chunk of sessions have 2 tasks, but a lot of these sessions have like a lot of more tasks as such. I'm going to skip this. So we do kind of categorize users to different types. So some of them might be focus user. A focus user just issues in a single session, they kind of talk about the same stuff, which is like some testing schedule or some questions that they're doing some online mock testing stuff. Multitasker kind of looks at some games in Walmart and a lot of different stuff. A super tasker is looking in a single session, they're kind of looking at a lot of information for a lot of different topics and such. Now this is important because the kind of system which works best for them would be different than the kind of system which works for the others. So you want to kind of, so in addition to the query grouping, you want to do user grouping as such and kind of have personalized systems for them as well. Skip. In general, the takeaway was this, that in general, sessions should not be the focal points because each session has multiple tasks. So this is me pitching to you that, you know what, you should consider tasks and do personalization based on tasks as such. More than 70% of sessions are multitasking. Users differ based on their multitasking habits. The search effort varies and topics and stuff. But overall, why I'm saying this is that in the past 10 years, a lot of IR work was based on sessions. They want to personalize results based on the session information. So this kind of analysis pitches that you don't want to consider task information as such. yeah, so now we come on to one. I'm going to skip most of it, but this is the exact code problem, and we're just going to look at one problem. We're going to finish in like 15 minutes. Let's keep it at that, and we can open it for discussions. And I have a flight to catch today. So now the problem now becomes, given a bunch of queries, which is everything, 6 million of them, you want to categorize them into tasks and then subtasks. So this is the first time I'm saying this word subtask. If you're looking at a complex task, like planning a wedding or planning a travel, then planning a trip is one complex task. The subtasks are finding flights, booking hotels, then finding places of interest, finding vegetarian restaurants. Now this is a decomposition. Now each of these tasks can be complex. Because if you want to book a flight, then you might want to look at which is the cheapest flight and which is kind of refundable flights. Or if you're looking for, and then you might be looking for visa information, this is again task in itself. So when you're looking at this kind of information, then you have these tasks and which kind of can be broken down into subtasks. And you want to do that given a bunch of queries from the log data. So this is the exact research problem we are working on. And you could do that for a lot of, this is search, but you could do that for any interaction you have. If you're on Amazon, then people find information on, you can look, because people browse on Amazon, right? You go to some product, you go to related products, you kind of issue queries, find new products, hover around and do this interaction. So you have user interaction data, and then you can segregate into tasks. If you have in other domain, then you can kind of think of it in a different way. Task in general is like generic. We are talking specifically for search tasks because I work on AI. So there are some few approaches which people have looked at. So one is a simple clustering-based approach, which works. I mean, it kind of decently works. There was a paper in, so Wisdom is another conference, which is web search and data mining. So if you see any paper from WSTM or from WWW, so these are kind of really tier 1 good conferences like KDD, and so Aspiring Minds publish a lot of KDD. So if you see a paper from there, just trust it. A pro tip, apart from all this, if you're looking at papers, if you're reading, so because, I mean, if you're into machine learning, at some point or the other, you would come across some paper to read what they're doing and stuff. Just know what are the good conferences to look out for. There are a lot of these, I wouldn't name them, but there are a lot of these not so good conferences because which have like really shitty review process, anything gets accepted over there. So just be wary of that, because whatever you read over there, you cannot trust them. But if you're seeing papers from like some established conferences where good research is published, then they have a pretty good reviewing system, so you can trust the results they have, you can trust the methods they have, and those are kind of good papers as such. So Wisdom is one of them, WWW is one of them, KDD is one of them. We just kind of, even if you don't know them, just kind of read it now, so that if at all in the next 1 year or so, if you read it, then you can see that, okay, I have read this stuff before, so I can trust it. So people started looking at clustering-based approaches, so they can have a bunch of queries in a session, they can cluster it. So I'm not sure if you're familiar with clustering as such, but clustering, you've been talking about supervised learning in the previous meetup. In clustering is an unsupervised way.